Hello everyone, I'm Xiaogang. Okay, let's start writing in this lesson. Since he used leaving coding, let's use it too. So let's try not to use this thing, I'm just demonstrating it here. For example, here I have enabled leaving coding. And note that in our VS here, we don't have debug here. Actually, we can debug, but it's here. Then debug, attach the process, and here we can browse all our processes. Or start with U, so we might need to scroll down. It's a feature, it should be. Okay, then touch. It needs to wait a moment. Okay. Now it's started up. Let me show you something I missed during the practical session last lesson. It seems I can't set a breakpoint here. Wait a moment. Now, if I can't set a breakpoint, forget it. Let's just cancel it. Maybe it's not him. He is correct. This is just a demonstration of a key point. We added an extra line of code here. We make it print twice. And actually, we should recompile here, right? Hopefully, we are at this point. We click this, code recompile, and reload C++ code for game. You can see it like this. After we finish recompiling, and then let's take a look. It should be fine. Then, when we start it up, you'll notice, hey, it will print out the new thing we just changed. Okay, no problem. But compiling here is clearly not going to work. Why is that? Because it will prompt you that live coding is turned on, and you need to either close the editor or somehow end the background process. That's roughly what it means. Okay, so let's continue looking further down. First, we need to create our actor class. Let's add a C++ class first. Briefly speaking, the actor class is quite important because basically all our games are developed further based on this class. Let's call it XG, fculture. Then when placing it, we'll just leave it here. Then it should be created. Then we can see, actually, at this position, it has already been created. Because we don't have touch now, so this part needs to be reloaded. We'll just reload it directly. No problem. Link it this place. Should be in leaving coding, right? But doing it this way will actually have some issues. If there is a problem, we just restart it and it will be fine. And in this place, we can see that the character is actually quite simple. When you look at it, it's still similar to our pump. Actually, in this character, a lot of things are written. You can see that character is also a pump. It has a mesh and collision, and at the same time, it has built-in movement logic. That is, it has this movement logic setup, and they are this. That is basically responsible for the physical entity that the player or AI interacts with in physics. And at the same time, basic input response and networking can be implemented. And they are designed to be able to walk. That is, to be able to walk, jump, and fly. Just like your own stuff. It has already been done for you. Just use these character. And what we need to pay attention to is that there is a mesh here. It is on this type, this object, TTR. Just treat it directly as this OBA point. Actually, at this position, you can equivalently understand it as skylight mesh. Point. This part is Karamerton. Just stars are fine, and it is private, but this place allows private assist. That is, the red marker is enabled, and it is visible to 02. It can be seen everywhere, but Blueprint can only modify it. Can only read it, cannot delete it, or anything like that. And there is a capsule collider here. And there is a CharacterMovementComponent. And this time, in the editor, this way of writing is, that is to say, only in the editor. We'll see this arrow in the packaged game. None of those situations will occur. This part is mainly to demonstrate the direction our character is facing. The class further down is a bit more complex. We won't go into it deeply. This mesh, getMesh, is the exposed method. Because this object is already private, so this getMesh is used very frequently. You see, it also has getCharacterMovement. Same with getCharacterMovement. Then here, getCapsule. Get some components of this capsule. Right, okay. Then let's continue. Continuing to look. There shouldn't be much else. Here, mainly look at this part. This part is mainly, you need to edit yourself here. Further something, just bind it, should be called this part. And here it has a jump and a stop jumping. Then can jump here. We will make some judgments, and inside this there is a variable. Let's jump back to this later. This is process jump. Let's go back to our character. First, let's do a simple test. Put this code into BeginPlay so we know it has loaded successfully. Okay, now let's do it directly through live coding. It should be ready here, but there's one problem. At this point, it actually has no effect. Why? Because you need to specify it here to specify it inside here. We specify it through the blueprint. I think this is more reasonable. And here, this is the player. Default. Let's change it. Actually, we haven't created our blueprint yet. So let's go ahead and create the blueprint. Let's call it, put the blueprint in front. Then let's specify it first. Let me emphasize again for everyone. There might be some points worth paying attention to. Let's change it here. Right here. That's it. Okay, compile and save. You can turn off the plug can. Then you can see right here. It's already done. This place is our, you can see this arrow. It is actually our waycomber. This component is our mesh. This is the capsule, right? That is our character movement. It is already here. Because when it is in the parent class, it has already been provided for you in the character class. Actually, it has already been done for you. You can see we come to its negative class. Here, you can see at this time we perform the bug. This rootcomber, you can see. Actually, the engine just does it this way. For example, in the editor case, compared to it, there is also a with editor, right? If we say it only, right, they are more or less the same. Then this place created this character movement component, and if sometimes you feel you want to create a custom one, it can also be done. It is done through this parameter. We have shown it to you in the LoRa. Okay, so more or less, let's come back. Alright, so basically, this is our blueprint instruction. At this point, let's execute it. You will find we are using FPS character. No problem. Right, okay, so let's continue looking below. We have already specified Mozart. Next, we need to start working on our mapping. We can see here, we find Eater. Project setting, okay. We are still using the old style. After this setup is done, we will use the new style later. Because we are just starting now, this old style is really easy to understand. There should be two here. Yes, here is the move forward. Okay, here is the move right. Here, we add one, then was. Okay, note the positive and negative signs, then make a distinction. Okay, here we also add a left and right. Then note the positive and negative signs. We also need to make a simple distinction for it. Okay? And actually at this point we need to make it move. Right, so now we start doing it. Turn this off. Sorry, I turned it off again. But it's okay. I'm used to it. I'm used to turning it off. This doesn't really matter either. Then we'll bind two functions. I just put it here. Okay, so we bound two mover functions here. For the work it needs to perform, we actually just pull it in directly. This is how we handle it in the middle. The main point to focus on here is getting this controller. What is this controller? It is actually our player controller. Right here, its parent class is a controller. Actually, this is the player controller. Then it controls this rotation. Then it turns, and it is determined by the direction of the x-axis. This is the forward direction of our current player. Then here we get the player's controller's direction. Then it is determined in the y-axis direction. It finds its right side direction. Then we call this function. You can take a look at this function. It is right here. this is like this inside character movement. To add this input amount, you can see it gets this movement component. Then in the component, call this input actor. Does it look familiar? If you don't have this component, maybe you forgot or something. It just dropped this thing. Yes. Okay. Then, so like this, actually, we already have a forward direction and a rightward direction. But at this point, we haven't actually linked them together yet. We need to do this in the SetupPlayerInputComponent. Only then will it actually perform the binding. Okay. No problem. Okay, let's start it up now. Then, let's take a moment to start from the top of the hour. I'll give you a demonstration, a little trick on how to read the engine source code. It's actually done by reading through this kind of comparison. Because in the last class, we tried to find that the start load in Unreal Engine, but it didn't seem to be there. But that's okay. Okay, now let's take a look. Later, we'll introduce a standalone program. Then we'll show you how the standalone program is structured, and we'll mainly look at this call stack. You can see it's in my game mode called start play, and here. This adjustment is actually called water begin play. So actually, this part is done through our game instance. In this place, this function here is the game instance. It is doing stop play here. In a game instance, through its adjustment, it becomes quite early. It might be through us. Because we are now in the editor, actually we have wrapped a layer, wrapped another. Editor engine thing, that is, here we click this button. Then we trigger this function. After triggering, you can see here, there's a world BeginPlay. Then at this point, it will first call the game mode. Game mode, this and then this will trigger the delegate. That is, the world starts the game. You can set about here and check again. Look, and this is where, before the game starts, a series of these operations will be executed. Okay, let's ignore some of these complex processes triggered by the engine for now. That is, by setting breakpoints like this, you can see how the engine actually runs. Actually, after you click, it will trigger within tick that something has been clicked, and then execute the task created by that click one by one. Okay, now let's let it pass through here. We'll ignore it. Good. Okay, after we start it up, we can see that we can actually move now, right? It's just that our left and right seem to be reversed. Let me check. For example, it's reversed. Let's check it a bit. Input low. Let's click move. Yes, our left and right seem to be written backwards, but we can just adjust it back. Okay, we'll ignore the breakpoint here for now. And here, for convenience, we'll just remove the breakpoint. In this lesson, we'll use this living coding for forward, backward, left, and right. You see, there's no problem here. Okay, then next we'll add the axis mapping. Add the mouse-related mapping. We found this input. Then we add a tar in this lookup. Double-click here. This is called turn. Lock. Okay, right? No issues here. Then here, the first one is this X. We need to find this X like this. And here is a Y. We find this Y like this. Then pay attention to this part. It has money 1.0 set up. Okay, then here, we need to do a binding. Then we directly bind it here. So, as for its binding, it is actually directly bound. Why can it be directly bound? Actually, the article explains it in great detail. It says that we are actually binding these two functions of the parent class. We can click in like this. You can see in a pen, there is actually this. It is actually something that can be input, such a sub-value indicator to drive our chain. You can see by taking our actor, receiving this binding, then getting our player controller, and in the player controller, removing this RTD sub. this ATD sub act are adding or subtracting the rotation input. That's it. You can say here it jumps to our player controller, because we will probably check a use pump. To control the controller's rotation, go to control the rotation of this pump. So note that here it jumps to the chicken class, jumps to the chicken class. The chicken class jumps to the player controller. This is how the functionality is implemented. Yes, then now let's test it. Let's test leaving coding. Let's check if we saved these. Remember to always save. Okay, no problem. Let's take a look. Hey, didn't you notice? Hey, now it can be controlled, right? Actually, our overall control is almost done. Now let's add our jump. Okay, actually, it's still the same. Let's go into this input. Okay, we find our action factor. And for this jump, actually the key we use is called, so we use the space key. We press the space bar like this, and that's it. Then to execute this method, it's relatively simple. We just need to declare two methods here, and then bind them. This U function is very important. I've emphasized this again. Yes, now let's create its implementation. Okay, then here, it is actually modified. These two variables, just change these two variables and it's done. So where do these two variables come from? Well, we directly click over to these two variables. Look here, inside the character machine. When it is true, this player wants to jump again. Then, when we release it, we will say that he no longer wants to jump. If when it is true, it will essentially perform a continuous jumping action. Then, now, we use our living coding to do a test. Okay. Alright, it proves that our living coding works fine. Alright, now let's press this thing. But it doesn't seem to have taken effect. The reason it didn't take effect is actually very simple, because we haven't done the binding yet. By binding, we haven't done this binding yet. We missed this step, so here we directly add this binding. Back in, map this direction, just add this binding to it. Then let's save it. We'll just use this. Leaving coding on the right to do it. Okay, no problem. Let's start it. Hey, you'll see, right? When you press it, it works fine. But it seems when you hold it down, it doesn't do a second jump, right? Let's look at the code again. It seems there's no second jump this time. Let's just ignore it for now. It has implemented the jump function now. Hey, okay, I'm just giving it a quick try here. It seems it still can't implement the continuous jump function. Let's leave it for now. Actually, you can look at these two functions. Let's go into its parent class. Let's go into our parent class, right here. Here, find this jump. Take a look. Yes, if you need to do some double jump operations. Actually, you can see that this jump is our start jump. It's actually the same. Here, compare these two booleans with a true and false check. Then perform some state releases. That's roughly the idea. Okay, then actually here you can directly bind the function of its parent class. So how do you bind the parent class's function? Actually, we remove this part here. We remove it. We directly bind the negative class. We don't bind this one. We don't bind the one we wrote ourselves. For the shape, we put it here. We can either delete this or keep it. Let's just delete it. Okay, let's hot recompile here. You see, there's no problem. When we start it here, it can still jump. But it seems that holding down the spacebar to keep jumping hasn't been implemented. We might need to write some more complex logic. Then at this point, we import this mesh resource. We still move it to our location here. Remember to fix our re-import. Then when we import the resource, actually we just directly here import the game. Then we place it in this location. We mainly download it and then import it into this FBX resource. we generally just import with, actually there are some options here. That is, generally if you don't check it, it won't go to morph target, which are our BS curves and such. And also some multiple LODs, you need to make sure to check it. Then you need to pay attention to the different PC software, such as Blender or Maya. Their default coordinate axis orientations, or these may all be different. You need to verify and confirm this with your art staff. After confirming the art specifications, import according to the standard specifications. Let's import directly. You can see that this material actually, it is what we saved. Let's save all to save it. See, this material is roughly like this, and actually, it should have textures, but it seems there are no textures. Then it can only be like this. Yes. Then let's ignore it. Cancel. It seems we just click yes. Okay. Save all. Let's put in FBX here. Then we better add another layer. If we add another layer, let's call it mesh. Let's just drag it in and play around. The way it's placed here isn't very standard. Let's just leave it like this for now. Then let's find it in our blueprint class. Then we have a mesh here at this location. Erase it at this spot. Then we specify it here. You will see. Then this task, we can do it in C++ or in Blueprint. We can even read from a table. Or now, we will proceed with doing it in Blueprint. We need to set its relative position here. Yes. See, like this. This way its relative position is fine. Then remember to compile and save the blueprint. Finally, let's test it in PA. Confirm it. You can see it looks roughly like this. Then we use F8 or debug with the semicolon. Press this semicolon and we can check it. I can already see with F8. Right. Oops. Let me check F8. FV didn't work. Let's try this one. There is one here. Hey, right. Because it doesn't have much debug info. It just pops it out. And you can see on my end, pressing F8 didn't work. I can press Shift F8 because it doesn't seem to have taken effect either. Then we might still use the Shift plus F1 method to bring it up. Then the PI here is brought in. At this point, we further add our camera component. You can see, because actually you will notice our camera is not working properly at this moment. Why is it not working properly? Because this character actually doesn't have a camera. No camera. What will it do? It will be at the scene's often at the scene's default origin. Go generate a camera for you. This way, this component. Answer, it has a view. So to solve this problem, we need to manually create this camera ourselves. Actually, we have already created this camera many times. It's very simple. We need to, in our, here, place it on top again. It doesn't really matter where we place it. We need to forward declare it like this. We don't want to. We don't want to include it in this header file. Then, in this source file, we include this camera component. Let's take a look. Okay, so after including the camera component like this, we can successfully create some things inside it. So in the constructor, you see, we haven't written anything yet. We directly create this camera component. This is the first-person component. This is completely fine. Okay, similarly, we attach it. Note that we attach it to our capsule, because we actually need to look at our character component and see what work its constructor does. You will see that in its constructor, it does this kind of work. You can see it creates a capsule and then sets the capsule as the root node. It's just such an operation. Okay, good. Other than that, there is also a rule component. Actually, we don't care much about it. This is under the editor. It is specifically used to indicate direction for us. And here is its mesh component. Now pay attention to this mesh component. It goes here to, it acts as our capsule. It acts inside our capsule. We created a camera component here. Come back, add it to our capsule. At this point, adjust the position of the camera. So you need to allow enabling this feature. That is to say, this camera rotation, between them, we look at this comment. If this camera component is placed on this pawn, then you should use these views or the controller's rotation. That is to let it control this pawn's orientation. So you need to enable this camera's function here. So it's okay. And note what this edge here is. This is setting the relative position. We just calculate this position. This is called base height part. It is also inside the fact. This means there is also an eye height calculation. What is this height used for? Look at 64.eve. Sometimes when we are working on AI behavior trees, you will find that if we enable debug mode for the AI, then the AI's observation from the eye to this position from its perspective might be related to this. That's why this is here. This is something worth noting. It's worth paying attention to than this place. Because if we set the default values, sometimes when you change the default values, we change the default values. That is, change all the default values. But if you set the value inside the blueprint, after setting the value, then modifying the default values will not change its value. You need to make it return to modern within the blueprint, and it will return to our latest modern value. Then at this point, 变色真机 we compile this. Actually, after finishing the editing, let's take a look. Hey, you can see there is a camera here. It should be at this position, but it doesn't seem quite right. This doesn't seem quite right. We can check it out. This camera is at the waist level. Note at the head level. We need to check. It seems like this part hasn't returned to the default value either. Not sure what was done wrong. Let's check it. If it's not troublesome, we may need to restart it. Then create a blueprint class and take a look. So let's close it. We'll just launch it directly from VS. Okay, there's a compilation error here. This is very normal. Let's restart it again. The reason for this compilation error is that the editor was just shut down immediately. You launched it immediately again. Actually, the editor process hasn't fully exited yet. Let's take another look at the camera's position. See, that's correct now. This means that this is why we emphasize this leaving cutting. Sometime this is completely acceptable and understandable. That is to say, some of your modifications to its values may not be able to respond in time. Next, we will add our first person mesh. Then we won't use this leaving cutting for now, because adding it later might cause other issues. So at this point here, since we already have a mesh, we add a second mesh. Then the second mesh needs to be declared manually. And here, you can actually use it like this. That's completely fine too. Like this. Just use it like this. They are equivalent. You can leave someone. Now you can leave someone. They are equivalent. Then later, we will, in the hook function, need to do a creation. Then we can just copy it over. If we copy it over, actually, you can see. Let's zoom in a bit. That is, we first create a scalar mesh. Then this cannot be empty. And at the same time, we make our first person mesh visible only to outside and also attach this to our camera. Then we want to avoid the shadow, right? Because only we can see it. Others cannot see it. So we don't need it to cast shadows. So this part is completely fine. No problem. Finally, we make our mesh. We cannot see our mesh. That's roughly the idea. Okay, after doing this, we will launch it directly. Here, we are not using Q. Alright, now let's start importing our assets. Still go to FBX. We'll give it a new folder. Mesh. Mesh dang hand. We'll write it like this. This is not very standard, but let's handle it this way for now. Then here, we import this thing. We should be able to import it directly. Let's save it. Then at this point, we open our character like this, such an accumulation. Then on our mesh here, we switch to the for viewport. Create a pair of hands onto this mesh. Then we need to do some simple settings for the data of these hands. Okay, as for these settings, it doesn't actually need to be too troublesome. we just copy the data from here. Then you can see, after setting it up like this, the position of these hands seems... Let me check. It's still not quite right. Let me take a look and readjust it again. That's correct now. Okay. So let's run it now. Let's take a look at the result. Okay, so we can just do it manually like this. Good. So for this section's work, we have basically completed it. Then let's continue looking at our documentation to implement the subsequent feature.